Okay, welcome back. So, we will start from where we left in the previous module. We were looking at the quantification of e-waste, like how to project how much e-waste would be produced, how to know, because whenever you design something, say if you are an engineer or even you are in doing some management stuff, or whenever we are trying to address a problem, first of all we need to know what is the extent of the problem. So, how big is the problem? So, in terms of this e-waste management, the one of the core information that you require is how much e-waste is actually produced, and that depends on how much e-waste is coming to the market, how people are using it, whether they are after how long they are using it, how long is the shelf life. And as you can see, being part of the society, you also observe certain things, while which if you have observed it carefully, previously the amount of years, the number of years that we used to use certain electronic product was much higher. Now it's becoming more and more I would say throwaway society, where we want to buy new things every time there is a new product out there, and the whole market is like that. We have this now this iPhone X is coming, iPhone X is already there. So then by the time this course will be over, there will be new model of iPhone, maybe before even earlier than that. So there is lots of new products coming into the market, and there is a peer pressure, like some of your friends, some of your colleagues has it, you want to have it as well because it becomes like a status symbol. So all those leading to all those different factors, the amount of electronics being purchased is increasing, and since they are being purchased, at some point of time they will be discarded as well. So in this particular module, we'll try to find out how to estimate. Say if you are given the job of managing electronic waste for a metro city in India, say Kolkata or Chennai or Bombay or Mumbai or Delhi. So if you have any base, we have lots of big cities now, Bangalore, Ahmedabad. So if you are in charge, how will you go about it? First, you need to know how much e-waste is being produced in that geographical region. So we'll try to do that math right now, how there are different ways of doing it. So I'll explain you one way of doing it. There are other ways of doing it as well. So and we'll take the case study of Kolkata to do that. So let's look at where we kind of started, kind of ended yesterday. So there are different method of estimating e-waste. One is the disposal related analysis. We talked about these like in brief. We just introduced these yesterday, so we'll come back and spend some more time on that. So we had one which is the disposal related analysis. So now what is that disposal related analysis? In that, what we are trying to find out is we try to find out e-waste figures obtained from collection channels, treatment facilities and disposal sites. So you go and get the data. You try to collect the data from e-waste recyclers, from dump sites or from waste to energy plants, wherever this electronic waste may end up to. So in that geographical region, you go and collect the data from different places where this electronic waste may end up, and then you take the data and then you use it for kind of having an estimate of how much e-waste is actually produced. You have the older data, then you project it in future, you can do the future projection as well. So what it requires empirical data from parallel disposal stream. So we have to look at the parallel disposal stream. It could be of course, it should not go to a compost plant, but it can go to a waste to energy plant, it can go to a landfill, it may end up in recycling centers, different types of recycling centers. So that's where we need to find out the data and try to estimate based on that. That's one way, that's the disposal related analysis, that's the one way of doing it. There are several other ways of doing it too. We'll explain 4 ways here and then do the case study using one method, which is the time series analysis. So this Kolkata case study that you will see in a minute or minute and a half is on time series analysis. So which is basically used to do a projection, like how much e-waste will be produced in future, taking the data from the past. So here, what does time series does? We try to forecast the trend of e-waste. So we take the historical data. So we'll try to collect the historical data for last, as long as if it's better, say if you have for last several years, best, like if you can go for a decade or 15 years, more the data, more the historical data, better it is for future projection. As you can, it's obvious, isn't it? If you have done a little bit of math and a little bit of statistics, you know. that more we have the background data to project something, we can come up with a model which will model, we can use certain, even for population forecasting for that matter. Whenever we talk about population forecasting, we take the data for last several census, and then taking, say for example, if I want to project the population of Kharagpur town for say 20, right now we are 2017. So, for 2021 or 2020, so what I will do, I will look at the data from the earliest census that we may have it available, say 1980s, 1990s, 2001. So, taking these three, we can come up with which method will work best in terms of forecasting. Then using that forecasting method, will project what should be the population of 2011. We have the data of 2011, so we can match to see whether it works good or not, and whichever method works best, we take that method and project it for 2021. So, that is how it is done. So, similarly here, but that requires having lots of data. So, that is why you need to have good amount of historical data which needs to be there. And then it can also be applied to fill the gap of a past unknown. So, if you have this is also used if you have some data, but there is in between certain gaps are there, we can use this we can use this historical data set to find out to get the data in between. So, if they will fill in the gaps in between for that. So, that is the two ways. Then we will look at two more ways of doing it, which is a factor model, where we use a determinant factor for correlation. So, here what we try to do is we look at the population size, we look at the income level, what is the population, what is the income level, and based on the income, how much electronics the population, certain population will be able to buy based on their purchasing power, and looking at the shelf life, the useful life of that particular electronic product. We will make certain assumption that after 3 years, and those assumptions are based on certain survey. It is not just we take certain numbers, all the numbers that you will use has to have some basis. So, there are a lot of surveys are done, you go and talk to people, like last time you had a laptop, how long you used it, and you do it for several different areas of the city, different types of people, young, old, and teenagers, or who are just in early 20s, and then you go into the middle level like 35 to 45, someone in my age group, and then you go further in terms of the older people. So, it all depends on how you get the data, and then you have to get the variety of data, and then you project based on that. So, here we look at population size, income level. Then this is the it's a complex. So, you don't see many papers or many reports done using this. So, there is a lot of complexity associated with that, and high uncertainty, because it all depends on how people responded to your questionnaire. So, there could be a certain problem, and then you have to do some advanced modeling technique. So, that leads to a certain problem in terms of using this model, but this is also one method available. You may find some literature out there using it. Then input output analysis, this is the most frequently used when multiple variation, like you do a mass balance. Input output analysis is essentially you do the mass balance. How much is the electronics coming into, say, city of Kolkata, and how much of electronics going out of city of Kolkata, people buying it, and then how much is being used within, and then how much e-waste is being produced. You try to do a mass balance, try to find out the numbers. For some big cities like Kolkata, Bombay, Delhi, and those places, we need to be careful that many times the electronics may be purchased over there, but may be used somewhere else in a remote village in other parts, the parts of the country. So, we need to kind of somehow find that fraction, and when we look at the input and output analysis. So, that's it's applied for the estimation of e-waste in many regional and country studies. So, when your area or geographical area is much bigger, this works a little bit better, because you are taking into consideration the local movement of electronics around that particular area, because your region is pretty big. But if you are focused on one particular city, this method again can be used, but you have to be careful in terms of all the data that will go in there. So, being said that, let us try to do a quantification example for Kolkata city. And as I said earlier, we will use this time series analysis. But this is you can do it for your city as well. You can see what kind of data is required. You can get those data for your city and then try to project. It would be a good exercise for you to do, especially those of you who want to do some research or some further study in this particular area. I would encourage you to do that. And of course, if you have some questions, put it on the discussion forum, and we'll be happy to answer that. So we will use the time series analysis, and so we'll try to estimate the e-waste generation and disposal quantities related to. So we basically we'll take the example of Kolkata city, and then using the Kolkata city data, we'll try to, after doing the Kolkata city information, we'll try to extrapolate it to the entire area, assuming that Kolkata city kind of gives a representative number. Again, that's an estimate. So, but right now our focus is Kolkata city. We'll include wide variety of items, which includes desktop computers, notebook, black and white and color TVs, refrigerators and washing machines. So, we will look at the variety of material, and since there are variety of material, there is multiple lifespan for different products. So, different products have multiple lifespan, and we will talk about that as well, high income group, low income group, and all those how this lifespan also changes. So, the basic model is this, and I will try to explain it in detail. Make sure that you understand this. If you need to replay this part of the video again and again until you get it, because if you get it, then it's much easier. If you don't, then it will be difficult to follow the next few slides. So, what happens? Like somebody purchases an electronic item. So, this is where we are starting. Purchasing of electronic item is what is happening. So, we are going to start from there. People are purchasing an electronic item. Then after certain lifespan, it becomes obsolete. So, obsolete means people are not using it, it's no more being used. So, it's an obsolete electronic item. So, once it becomes obsolete, say for me, it can still be in a usable form. So, many times what happens is you have some obsolete old mobile phone, probably maybe your first smartphone, which is it is a smartphone, but not as smart as you want the new phone to be. So, you may give it to your some people like your driver, sometimes we give it to the maid servant, or even to say auto wala, rickshaw wala, whoever is there in the society who you think may benefit, and then so that becomes its reuse part, and that also happens. Many times you may sell it to a reuse shop, and then reuse shop owner will use it. So, they will refurbish it, make it look a little bit nicer, clean it, and then if needed change the screen and other stuff and then sell it as well. So, that is sold as refurbished, much cheaper, and they also make profit out of that. So, there is a different ways things could be reused. So, that is one particular option is there where things could potentially be reused. Then other option is since it is obsolete, you store it for a little while, because as I was telling you in the previous module, we always have a lot of emotional attachment, unfortunately, to many things in our life. So, it may get stored. We have assumed, I think over here, which in the next slide we explain that, I think we assume that maximum 3 years. So, 3 years people will explore and store, and then after that it would be thrown away. Or it could be send it to a recycler and recycle, either informal or formal recycler, and then or it may end up to the landfill. So, this is what potentially can happen. So, from obsolete electronic items. And then in terms of again further, if it goes to the reuse, now it is again being used as a product. So, it can further be recycled, stored or recycled, or going to the landfill, like you saw the choices here. So, same thing can happen on that scale. If it is stored for certain number of years, then again it can go either to the recycling center or to a landfill. So, that is another scenario. And here again a reused item after reuse for few years, not again if it is stored, it can go to recycle or to a landfill. So, this is what we have assumed of what is happening, and it's logical as well. This is what and this is when I say we have assumed, the people who use this time series analysis, the way the time series analysis have been developed, this is the basic model of a time series analysis, and it's true for electronic waste, it's true for other waste stream as well, it's true for other projections, whatever projection we do using this time series analysis. Similar, so it may not be exactly, because they store, recycle, landfill, it's mostly for waste, but other parameters will be there, but similar concept is used for this. And here, guys, this X, as you can see, for all these boxes next to those phrases, next to those words like recycle, stored, landfill, we have x1, x2, x3, x4. So here x1 to x11, this is the fraction. It's the fraction of the obsolete electronic items for various EOL. EOL is the term used for end of life. You will see that being used many times in this course and any waste related courses. So it's end of life scenario, which is could be reuse, could be stored, could be recycle, could be landfill. So this is what we are talking about. And then this x1 to x11, that now we have to give certain weightage, and that weightage depends on, after doing an elaborate survey of how things are happening on the ground. So you will go and ask lots of questions, you will prepare questionnaire, you will do lots of questions, you will ask questions from different places, different strata of the society, and then you come up with x1 to x11 values. And of course, you need to justify why you have taken that. Say if you are doing a master's thesis or a PhD thesis in this area, you are going to use this model, you have to get this x1 to x11 values, and then based on your survey, based on your data collection, but you need to again give a very thorough explanation of why it is being done the way it is being done. So being said that, let's see the next stuff on that. So next what we will do, we will make certain assumption, which is again any analysis you do, you have to have certain assumptions. So what the assumptions are: total ban on illegal exports of electronic items. So there is no illegal export of electronic items happening in this Kolkata city area. So no illegal export. Lifespan of reused and stored electronic items are considered as 3 years. So we have, as I said earlier as well, we have taken 3 years. So this again based on all the survey, based on all some of the data that is collected. Now the 50% of the total reused items are further stored for another 3 years. Whereas 20% and 30% of the items are recycled and landfill. So for x5 we are using 0.5, x6 is 0.2, x3, x7 is 0.3. So we are using these 3 numbers for that. So again, these assumptions are based on certain data collection on the ground, and we'll talk about that in a minute. 20% and 80% of the stored items are recycled and landfill. So 20% of the items are recycled, 80% of the stored items are actually landfill. So for that we put this x8 and x10 is 0.2 and x9 and x11 is 0.8. So which is coming from the previous slide. So these these assumptions have been made, and these assumptions have been made based on the data collected on site. So what was the data? This data collected from these 2 studies, which was done in Kolkata area, which is first one is by Dwivedi and Mittal, and we will as a reading material will provide you. The plan is for this course, for most of the background reports and papers that we are going to use in this study, will provide you either the link of that report if the report is or if it's available on the web or freely, or we will download that paper and upload that paper as an additional reading material. So you will have those as we make progress in the course. So if you're more interested to go and learn about that, go and do that, and again discussion board is there to ask questions. So based on these 2 studies, which was one was the GIZ study, which was done in Kolkata. GIZ is a German firm. It's not GTZ, that should be actually GIZ, which is I'm sorry, it's a mistake over here. This should be GIZ, not GTZ, which is a typo. I'm sorry for that. And then here in terms of basic data, we have taken refrigerators, televisions, desktop, notebook, DVD players. So average lifespan is 11 years, 9 years, 7 years for household, HS is household, 5 years for the business establishment. As you know, like desktop computers in offices, they get replaced much quicker. In a house setting, we try to use it for a longer period of time, because in house we just do some basic stuff. Still the desktop is good enough to use. And notebook, 4 years, DVD players 4 years, and then the average weight of this is also provided to us, which we can use to find out in terms of the metric ton how much waste is being produced. Then this is based on based on Dwivedi and Muttal in terms of average lifespan that they have collected. They have tried to provide the data using surveys. And then in terms of the product type, all values, the method of disposal, whether it is reuse, landfill, recycle, or it is stored, we have got these values in percentages from this GIZ study, which is again based on all surveys. So, as you can see, for different types we have different numbers, and whether it is being reused, whether it is going to the landfill, or it is going to be stored, and all these should add up to 100. So, which you can see that they do end up to add up to 100. So, either 37%. So, take an example of mobile phones, 37% is reused, 7% is said to be going to the landfill, 50% is recycled, 6% is stored, and 50% recycle is again mostly informal recycling. Similarly, you can see the other ones as well. Refrigerators, 83% recycle. So, we are already seeing lots of recycling happening for all the different types of electronic product, but mostly it is happening in an informal sector. So, that is another situation we have, where we want it to be happening in the formal sector, at least part of it, which causes environmental and human health problem. So, using the data, and this is lots of numbers here, do not worry too much. Again, the slides will be provided to you, you can look at. I will just explain it to you how we got these numbers. So, based on projected input cell figures for estimation of e-waste under Kolkata Metropolitan Authority, that is the KMA. So, here from 1999 until 2016 and 17, we try to get the data, and for these data which was available from the different sources on the web, and some data is not available in certain years. So, that is why you see them blank. The data, unfortunately, some data is not available for certain part of the time. So, that is why you see these blank spaces. So, whatever data was available, we have tried to put it in here. So, refrigerators, this is the how much was projected or input cell figure based these many refrigerators was sold in these many years. This is for the DVD player and the household computers, business computers, notebook, and desk television. So, whatever data we could find, we have provided it over here. Other than DVD players, most of the data is from 2015, 2016 and earlier, not the recent ones. So, now why this data is important? Because based on this data, using the lifespan of the product, we will try to project in terms of what will be the future, like how much will show up in the disposal stream. So, this is your total. The previous table that you saw was the input stream that is coming in to the system. Now, using those all x1, x2, x3, x4 figures, which we have based on the assumption that was presented to you a few slides back, as well as the data that is collected out there, we have this x1 to x11 data, x1 to x11, and it is different for different items. For television, refrigerators, DVD players, as you can see, these values are different. Again, we will provide you that paper, we will provide you that so that you can get that. If you want to study more about how those x1 to x11 were arrived at, you can see that. But the basics has already been explained. So, based on those, so we got these different like weightage values. And then we come up with these equations, and these equations, as you can see, this looks a lot of it may look a little bit clumsy, but don't worry, it's not that difficult, and which I'll just let me show you the equation, and then I'll explain a couple of them in the next slide, so that it becomes easier on you. And then this is for the first table we saw for 3 items: television, refrigerator, DVD players. Here we are looking at desktop and notebook. So, now what are these equations are all about? You already know x1 to x11, we have talked about that. So, what are these equations? Where here RU, as you can see, RU is the reused items, as we have used RU for reused items, and OK is your quantity of obsolete items for the year K. So, for that particular year, how much obsolete item is there? 21% is being reused. So, that is how we are getting those numbers for desktop. For notebook, 37% is being reused. So, that is how we are getting those numbers. Then ST is your like stored items. ST is the stored item. So, we can get similarly ST is a function of how much quantity of its obsolete item for year k minus 3 years. So, because in 3 years we store it after the lifespan of 3 years we are storing it. So, that's the store item for there. Similarly, which are 6 years before the year of consideration, there is another OK minus 6, which is quantity of item which are obsoleted 6 years before the year of consideration, and RC is the recycle item, LA is the amount to be landfilled, and ST is the stored item. So, you can come up with all these equations based on that. So, this is how you can do this estimation for different parameters. Again, you have to do some self learning in this course too. I will encourage you to use those equations and try to come up with this table that we are showing you right now. This table that I am presenting you to right now, this can come up with, we have used the same equation which is shown in the previous 2 slides and come up with these numbers. So, I encourage you to at least do it for either television, refrigerator, DVD players, at least 1 or 2 items, do it so that you feel confident that these numbers are correct, and this is how the numbers can be arrived at. If you find some problem in our calculation, let us know that as well, because we can also make mistake, but we have tried to check it to make sure that we have not made any mistake. Of course, there are so many calculations involved here, so it depends. I would encourage you to use Excel sheet, and that will help you to minimize any error. So, based on different items, this is the unit, how much numbers. So, this is in terms of the numbers, how much electronics are getting obsolete, reused, stored, recycled, and landfill for different period. So, for the different items you can calculate based on the equations that was provided in the previous slide. So, and then you can estimate the quantity again for the other items, notebook, desktop, household, desktop, business. So, that is again you can get the unit number, similar calculations have been done for that as well. So, and then the number and weight, because we also had the weighted weight associated with that. For each one of those, we had given the weight, how much they weigh. Remember the previous table we had where we had the average weight of different components. So, based on that we can from the unit numbers we can multiply with that unit number, we can multiply it by the unit by the weight and get the in unit kg. So, that is also important to know how much kg will go into the disposal stream. And as you can see over here, let us go back to the table. For certain items, this is for total. If you look at individual items, you will find that certain items they are although the weight numbers are very high, but since their weight is much less, when you go in terms of kilogram, the number goes down drastically. The same information has been presented here in graphical. If you are rather than from the table, we presented in the graphical in terms of the different years. Number of products is the x axis, years is on the y axis, and 3 items here: DVD players, refrigerators, and television. What it shows that more and more televisions are coming up into the disposal stream as opposed to refrigerators and DVD players. After television, it is the DVD, then it's refrigerator. It gives a good spectorial description. And same thing for, we see that desktop business computers are coming up in very high number. Then we have notebooks. Notebooks are being changed more frequently, and then you have the desktop. The blue is obsolete. Many times you see that obsolete numbers are much higher. So, blue is the total obsolete computers that is coming out, and then the other bars, which is reused, stored, recycled, and landfill, they will essentially, if you take those numbers, again the reuse is the orange, stored the gray, recycle is the yellow, and green is the landfill. And we see that the yellow portion seems to be much higher in most of these categories, which indicates that more and more of these is being recycled, but mostly in an informal setting. So, again in terms of the numbers, estimated end of life for different years, when we add these numbers together for different types of electronics, we get again for different years, as the number of years it is getting more and more, as you can see. As like the blue is for 2016-17, orange is for 17-18, purple is for 18-19, and then green, blue, yellow is from 19 and 20. And you see as the number of years are going up, more and more electronics are being disposed, both and from the weight as well as from the numbers from the point of view. So with that, so this is how we can estimate. This is how we can estimate the e-waste quantity, and that's so we had looked at how to do the estimation. There were 4 different ways to do the estimation. We did like a quick overview of that. Then we all looked. We took this 4. I think we 6 items from yes 3 and 3, 6 items we took, and we tried to estimate using the time series analysis for Kolkata city, using the data available in 2 different literatures, and then collecting those data. We have not done our own data collection. We just relied on the data which was there available in these 2 study, and then we use this time series analysis to come up with these to illustrate a case study for you to how to estimate. So with that, I think you should have understood how to say, if you have to estimate for your city, you should be able to go ahead and do that. And but again, any questions, feel free to put it in the discussion forum. We'll be more than happy to answer. And again, I'll see you in the next video. Thank you.